A function f of x is given as x cube plus e to the power of x by 2. And how is the function g of x? G of x is the inverse of f of x. What is required? The derivative of g at 1 is required. Yes, it is quite difficult to find the inverse of this function g of x as a definition of x, right? So what we do? We'll use the properties of inverse functions. Given relation of f of x is x cube plus e to the power of x by 2, and we are given that g of x is the inverse of f. Now when do we say g is the inverse of f? Yes, clearly the composite function of g circle f of x would give us x. Now what happens if we differentiate this relation on both sides with respect to x? We get g dash of f of x, chain rule, times f dash x is equal to 1. So what is g dash of f of x? The value of g dash of f of x is 1 by f dash x. This will treat it as an equation 1. We need to calculate g dash of 1. So first let us identify when will be this f of x becomes 1. For f of x to be equal to 1, that means the value of x cube plus e to the power of x by 2 should be 1. This is possible only if x is 0, right? Then this part becomes 0 and this is e power 0, which is 1. So we got the value of x equal to 0. Then from the equation 1, what did we identify? G dash of f of 0 is 1 by f dash 0. But what is f of 0? F of 0 is 1. So therefore, g dash of 1 is 1 by f dash at 0. Now can we find the value of f dash at 0? Yes, that's a very simple function because we know the function f of x. So let us calculate from the function directly f of x being x cube plus e to the power of x by 2. What is f dash x? The value of f dash x is 3x square plus half times e to the power of x by 2. So what is f dash 0 now? The value of f dash 0 becomes 3 times 0 square plus 1 by 2 into e to the power of 0, that is 1 by 2. Now we got f dash 0, so can we calculate, substitute in this? So from the equation 2 which we got, g dash 1 would be 1 by 2, or the value is 2. So what is g dash 1? The value of g dash 1 is 2, which is present at option B with us. Without finding the inverse of the function f of x, we have calculated the derivative at the point 1.